Now this session we are going to see about hexa to ASCII conversion, hexadecimal to ASCII conversion using 8085, hexa to ASCII conversion using 8085 microprocessor. So we know that 8085 processor is an 8-bit processor and it deals with hexadecimal numbers. How a hexadecimal number can be converted into a ASCII, that is what we are going to discuss now. So here if you see here, we can take any example of an hexadecimal number. So we know that whenever we want to convert a hexadecimal number to ASCII, we have certain conversions available. So based on the conversion, let's see. Let me take a hexadecimal number. Like if you have 0 to 9, we say that. Okay. So 0 to hexa number. The corresponding ASCII is 30 to 39. In the same way, we have A to F, hexa A to F. So the ASCII value is between 41 to 46. 41 to 46. So let's take any one example and then let's see how the program is written. So when I consider here, let's see, we'll start with the program in this way. LXI H comma 4500. As you all know that LXI means HL is moved to 4500. HL is loaded with 4500. 4500 is your memory location. So let's take the first data. Let us take an example of 03. So we are taking a hexa number of 03. So here 03, how the ASCII equivalent is got is, here it is being split into 3. For 3 it is 33, the ASCII equivalent is 33. For 0, the ASCII equivalent is 30, because we said like 0 to 9 already we said. For 0 to 9 it is 30 to 39. So for 3 it is 33, for 0 it is 30, for 1 it is 31, for 2 it is 32, for 3 it is 33. So that's what I've written. So we'll get a splitted result like for 3 the ASCII equivalent is 33 and for 0 the ASCII equivalent is 30. So this is what we will get it. Now we have taken the first memory location 4500, in that we have loaded the hexa value 03. So let's move that memory content to accumulator. So after moving that data to accumulator, let's mask the nibbles. So we give something called ANI0F. So it is nothing but ANDing the accumulator value and the accumulator value with your 0. This is being basically done for masking. So when I do ANDing, let's write 03, because in A we have 03. So I write it as 0000 and 3 is 0011, 84214, and my F0F it is. So I'm ANDing with 0F. So I write it as 0000 and then 1111. F is 111. So when I AND it is nothing but x dot y. So when you say AND, it is x dot y. So 1 dot 1 is 1, 1 dot 1 is 1, 0 dot 1 is 0, 0, and here everything is 0, 0. So my content is I get the same 03. So I get the 03 after ANDing. So it is masking the lower nibble. So it is masking the lower nibble, making 0000. So I'm getting 03. Now after doing the AND operation, let me call a subroutine here. So I say that call subroutine. I write it as SR. So what is that subroutine telling? Let's see. Let me have that subroutine here. So I write it here, my subroutine. So what is that? So you're calling this subroutine. What does the subroutine do is here in the subroutine I'm telling that compare CPI 0A. So compare the value of accumulator with 0A. So value of accumulator is what? Now it is 03. It is compared with 0A. Okay. Whenever you compare, you have to check for carry flag. So I introduce an instruction jump on carry. So if there is a carry, go for some loop. If there is no carry, do some operation. That is what they need to say. If there is a carry, what they do, they're giving an instruction called ADI 30. ADI 30. Add 30 to it. Add immediate value 30 to the respective value. and then move the, and then you increment it, increment one location, and then you can increment the HL pair, because let's say h, 4500, that is the first instruction we have used, so we can go for incrementing. Here it says that what it is saying is, first it is comparing, you're comparing with 0A, because after ANDing you get the answer is 03, and after 03 you're calling SR. SR is your subroutine. So what does the subroutine says? The result you're comparing with 08. So what is the result? 03 is stored and accumulated, is compared with 08. Now 03 is actually less than 03 is actually less than 08. So we know that it is less than 08. So there is a carry set. If there is a carry, add 30. So 03 is added with 30. Okay. So after that, what you do? You are incrementing H. Increment H is already H is 4500. Now you are going to have it as 4501. There is a carry, you are adding 30, and then you are incrementing your location 4501, and then you are adding, you are moving your accumulator content to M. M is 4501. What is A? After added, it becomes 33. So answer is 33. It is moved to accumulator, and then you are giving a return. You're giving a return. So this is what. So whenever we have a carry, we do some function, but if there is no carry, there may be a condition, there may be no carry also. So during that time, what we do is, we're adding 7, we'll add 7, and then add 30. So to bring a ASCII equivalent. So add 7 and then add 30. So this is what the concept is. So now we have got the answer 33. Again, after you have to return. It is returned to main program where it has left. Now what it does, so call SR, that is the last instruction we saw. Now what you do, you're giving LDA 4500. LDA 4500. What is there in 4500? Again the same 03 data is there. 03. So after that, you're doing an F0. Initially you did not F, now you're doing F0. So how that F0 function will take place? So you can see here itself. So here I'm going to have F0. So 03, let it be same thing like that. Let me erase this alone. And I'm giving F0. So how do I write that F0? F0 is 11110000. Now I do that x dot y for this. So I get 1.0. Everything is 0. Everything is 0. So the ultimate result is 0, 0. So when I do F0, the final result is, what I get is 0, 0. So I'm storing 0, 0 in accumulator. So masking the upper nibble here. So initially it masked the lower nibble, now it is masking the upper nibble. Now I've got 0, 0. So that is stored in accumulator. Now what do? I give 4 RLC. RLC 4 times. It is nothing but rotating the accumulator content left to carry. What is it? Rotating the accumulator content left to carry. Now the accumulator content is 0, 0. So whatever you rotate, the final answer will be 0, 3. Why this rotate 0, 0? Because already the value is 0. Whatever you rotate, you get the value 0, 0. Why this value 0, 0? Because you have rotated 4 times. Already it was 0, 0. Now again it has become 0, 0. So why this rotate instruction is used is, sometimes you have 30. So when you rotate 4 times, it becomes 0, 3. So in order to make that, only you have this rotate instruction. So you are just swapping the bits. So we have given 4 times. Now RLC part is over. So 4 times you've done. Again what you're doing, calling SR. You're calling a subroutine. So when you call a subroutine, where it goes, again it goes here. Again it goes here. So when it goes here, again it is comparing. What is A now? Now A is 0, 0 because the result is 0, 0. 0, 0 is being compared with 0, A. Again, it is lesser than 0, A. There is a carry set. Jump on carry. There is a carry. So when it is jump on carry, moving to loop L1. So when it jumps to carry, it has to move to loop L1. So initially also the same thing. So L1, you are adding 30 to it. What does L1 do? Add 30. So 0, 0 will be added with 30. So your result will be 30. Now you are incrementing your H. H becomes 4502. 4502. Initially it was 4501. And now we are moving accumulator content to memory content. Now current accumulator content is 30. So you are moving as 30. 30 will move to accumulator. Again you are return to main program. So where we left in call SR we left. So it will out the program. So when you call your subroutine, what it is doing? Again it is going to the subroutine call, comparing with 0A. What is there in A? After rotation only 0 is there. It is being compared with 0A again. So 0 is less than 10, 0 is 10. So there is a carry set. So when it is a carry, you are going to this loop L1. So what it is doing? Add 30. Add the accumulator content to 30. So 0 plus 30 becomes 30. And then again you are incrementing, it becomes 4502 because initially it was 4501, now it is 4502. And you are moving the accumulator content, that is 30 to memory. Memory is 4502. And then you are returning the main program where it left. So after call SR, you are giving a halt. So from this, what we can conclude is, in your result, if you can see, in 4500 there was the content 03, and I told you that we'll get an equivalent of 33 first, again 30, we got the same thing. So in 4501 we are saving 33, and in 4502 we got 30. We got the result 30. So this is the ultimate result of your Hexadecimal to ASCII conversion. So in the same way you can do for all the numbers in C. So it is a very simple program. Thank you all.